make sure you pick it up. RHS Pre-calculus presents Ellipses with Ellie. Everyone knows what a chicken is, but does everyone know what an ellipse is? Probably not. That's why today, Ellie will help teach us about this fascinating topic. And to make it easier, she'll show us using her real-life experience.
Hi everybody! Today my goal is to make sure that by the end of this video, everyone knows exactly how to look at an ellipse equation and know how to find the vertices, foci, and the center coordinates. As a perfect example, I've brought my own oval-shaped egg. I really want to see what it looks like on a graph, so we better hurry and solve this equation before she hatches. First off, what is an ellipse?
An ellipse is a group of points that creates a circle-like shape around one centered area. The standard form of the equation is x minus h squared over a squared plus y minus k squared over b squared equals 1.
The equation we will be solving is x minus 1 squared over 4 plus y minus 2 squared over 9 equals 1.
The center of an ellipse is found by knowing both the h and k within the equation. Although both the h and k appear negative inside the parentheses, the coordinates will be positive. If the numbers were positive inside the parentheses, then the coordinates would be negative.
Therefore, we know that the center of this equation is 1, 2. Now moving on, what are vertices?
Vertices are typically the highest point of something.
Like the roof on a chicken coop.
Yes, but in math analysis, they are known more as the vertex or the highest and lowest values on the major axis. The major axis is the axis that is parallel to the longest length of an object, either the x or y axis. It's good to know that the vertices and foci are always on the major axis. To find the vertices of an ellipse, you'll need to know the values of both a and b. As seen above, we already know the values of a squared and b squared.
Yes, a squared equals 4, so if we take the square root of that value, then a equals 2. And the value of b squared is 9, which means that b equals 3.
Be careful which number you choose, because first you need to make sure if the ellipse is horizontal or vertical. To be sure, there's an easy way to check. If your equation is horizontal, then that means a is greater than b, while a vertical equation means that a is less than b.
So since in this equation, b, 3, is bigger than a, 2, then that means that my egg will be graphed vertically. And now that we know it is a vertical equation, we also know that we need to add b to k. In other words, the coordinates for the vertices are h, k plus b, and h, k minus b. The final coordinates are 1, 5, and 1, negative 1.
If the graph was horizontal, then the coordinates would be h plus a, k, and h minus a, k.
Now we can start to see the shape of my egg. We know the length and where the center is, so this is enough to know the placement and the height. We can also assume that the graph is an oval shape since it is an ellipse. But there's one more thing we should do before we finish, and that's calculate the foci.
A foci is one of 2 points which help to generate an ellipse. These points are a little bit closer to the center than the vertices. To find the foci, we need to know the c value and add or subtract that from the center coordinates, depending on if the ellipse is vertical or horizontal.
We already know that, though. My egg's ellipse is vertical.
Which means we'll subtract c from k just like the vertices. But first we need to find the value for c. The easiest way to find this value is using the equation c squared equals b squared minus a squared. Just replace the variables with what you already know.
B squared equals 9 and a squared equals 4, and after subtracting them, you get 5. Take the square root of that, and the square root of 5 is c. This means that the foci are 1, 2 plus the square root of 5, and 1, 2 minus the square root of 5. And now we can graph my egg. Here's the center and the vertices, the foci, and the entire ellipse.
The end.